All right. Hello, hello. Welcome to Live at Loop. It is season two, and I'm joined by Mr. David Blackburn, execution lead at Loop. Got Josh Polanski, our technology lead and lead developer, and Jonathan McLean, breakout star of Loop season one, live at Loop. From our new machine concept team, I'm David Nichols. I'm the CEO of Loop. Excited to be streaming to you live from all of our houses and basements. And apologies in advance for any small children who might break into the scene or start yelling in the background. Hey, we all need haircuts. You know, this is just how we're living right now. But the work continues because we're here and we're still designing machines. Want to say a special shout out to Allison and Jeff, who are back in our virtual production booth. They might bump in at any time with any comments from all of you people watching out there in the world. And yeah, let's jump into it. We're going to shoot for about 30 minutes. I'll give a quick intro just as a reminder of why we're here and what we're doing. Then I'll turn it over to Mr. Blackburn and we'll just snipe and make snide comments while he tries to lead the meeting in an orderly fashion. So, live at Loop. What are we doing here at Live at Loop anyway? First, super big picture. Why does Loop exist? Why do we get out of bed every morning? What are we excited about? We think that there are amazing possibilities to revolutionize automation. So that's what we're here to do. Work with new technologies, work with better processes. Let's make manufacturing machines more amazing and capable than they have ever been before. Live at Loop, season two. We're building a track packer, which I will explain in a minute. And we're also going to be talking a lot this season about our development process, which is, it's based on Agile. It's based on some of these iterative processes where let's kind of build this as we go. Let's build it step by step. Let's learn as we go. I'll be talking a little bit about that too. You're tuning in to watch us do that in real time. So we have no idea what's going to happen. We'll be just as surprised as you with the outcome. So why are we doing anything in terms of a new machine? We've been working a lot in packaging automation since forever, and there's been a lot of interesting trends in there. One of the biggest ones is accommodating a lot of new different types of products within similar machines without having any kind of manual changeover processes. So there's some new automation technology coming from BNR and ABB that we think could support that. And so we came up with this sort of reference design, this prototype kind of machine. Hey, wouldn't it be amazing if the machine worked like this? It's basically a re-architecting, a rethinking of how a case packer could work. We call it the track packer. So we spent season one taking this from a cocktail napkin sketch into what you see here, which is this beautiful rendering of how this machine would work. We did a lot of study on what parts would we need, what would the track layout be, how could that technology best sort of unlock this new potential for this machine. We're really excited about working on it more, and so now we're going to be working on the development side. Let's make a digital twin of this machine, and in order to do that, we're going to be using our engineering process, which is called ship in six. What that means is we take a fixed amount of time, so 6 weeks, it's a sprint. We're going to do as much as we can, or we're going to build some version of that product against a feature set that we have in mind in a 6 week sprint. When the time's out, pencils down, that's all we're going to do for now. And then we're going to stop. We're going to take a look around. We're going to think about it. We're going to test it maybe. And we're going to, rather than signing up for this years long or thousands of hours development, we're going to build it 6 weeks at a time. We feel like that's a faster way to arrive at a better product in the end. And we'll be talking this season and we'll just be showing how we do that in typical process. It's kind of unconventional in the automation world, at least as far as we know. And so I just also want to give a shout out to the crew at Basecamp, in particular Ryan Singer. He wrote a book called Shape Up, which you can go and check out on their PDF. They talk a lot about their development processes. He's a really deep thinker about how to come up with new things, how to create new software, and he explains all these things in great detail about how and why they work at Basecamp. We don't do it exactly this way because it's a slightly different context, but a lot of the thinking and inspiration comes from there. And whenever I think about how would I explain this, about why we do it this way, I usually just go steal his blog posts and link to things about that he's already written because he does an incredible job of describing that. So thanks to Ryan Singer for all his work there. So that's the end of my intro. And Blackburn, you're the meeting lead. You're the execution lead. You're the one who's going to be steering the ship here. So I'm going to give you the focus and let's go ahead and get into this. You've got an agenda. A little embarrassing that I just talked about Basecamp and I'm showing an Asana screen here, but just never mind that. I know if anybody's watching at home and asking why, we also use anyway. Love you guys. Okay, so Blackburn, take it away. I've got your screen up here in the center. Actually, I'm going to make myself a little smaller so that we can see you better. And yeah, let's go ahead and get into it. Take it away.
Okay, so here's our Asana project for this effort. Last week we had a bunch of bullet points and I translated those over into Asana tasks that we will use as a starting point for our scope. One of the big tenets of Ship in 6 is variable scope. So as you get working, you discover what's hard and what's easy and what is not feasible for your 6-week scope. So what we have here is our starting point, and it will change as we work. And one thing we want to get done ahead of time before we get into that, adaptive variable scope process is the broad strokes. Are there any things that will drastically affect our ability to complete this in 6 weeks or drastically change our approach? So I'm going to do that first. So that's what we have here to talk about today. First one is, will we use Robotware and RobotStudio to control the robot, or will we take the approach of using automation runtime, which is B&R's real-time operating system, to do the machine control and the robot control? So now I will open it up to the rest of the team.
Trade-offs.
What do we think?
Yeah.
I think, like we were talking about last week, it'd be nice to incorporate the RobotStudio stuff. But if I think about the deliverable, the project, we have a 3D view of the scene that is the machine running, and so it doesn't necessarily mean that we would need this is sort of like a back end question, like behind the scenes, behind that, what's animating that? Is that coming from RobotStudio or not? And Jonathan, you had looked into what it would take to do that and distribute it, because that was the other thing, is we want to be able to get this in people's hands without a huge amount of overhead. Do you want to? And that to me might be the most important part of the decision, was just like, how can we get that to people's hands?
Yeah, it's a little tricky. I know last week we talked about, hey, wouldn't it be really nice if we could basically have two headless systems that are kind of standalone executables that we could just deliver a customer, and say, run this thing, and then the UI pops up and then they can interact with it. And we can do that for the most part with on the automation runtime side. But when you bring RobotStudio into the mix, in order to be able to run the virtual, you actually have to be running an instance of RobotStudio on the machine that is running the virtual controller. I looked into it for a while. It looks like there's no way around that. And I also looked into the fact, well, could we just send this to somebody, and it wouldn't be ideal for them to load RobotStudio. But in order for you to get the functionality of the virtual controller, you have to download. You'd have to download a 30-day file of of the version that offers that. So it would be, if we're talking about distributing this locally, like if the idea would be, you can download your own copy of our track packer from our website or whatever, then I don't know how, that's not really a solution. But if we're talking about distributability in a different way, I think it could maybe be work. So I don't know, when we say things like distributable, like what is everybody envisioning for this particular project?
I think the big dividing line for me on what's distributable, kind of as a not being out of the day-to-day grind as a developer, is like, I typically don't have like all the latest tools, all the latest IDEs installed. And so we found over the years it's helpful to kind of package those things where it can be just here, here's CEO, here's an installer that you can run that will, you can put it on your computer and you can interact with, you can run the whole machine without having like the entire tool chain behind it. Versus like most of our developers, you just be like, RobotStudio, it's like, of course it's on their computer, it's not a big deal. So I mean, I don't know, Josh, I see you nodding your head. Do you have a thought there?
Yeah, I think that's a big part of it is, you know, the target audience for this thing, and it is, it's probably not the dev team that's going to be running it the most. I think, RobotStudio does have things like pack and go, where like if you have RobotStudio installed, you can ship it with everything. But that does depend on having the correct Robotware versions installed, along with RobotStudio, having your system set up correctly. But again, and that's great for sharing between developers. But when you're talking about like putting it on a website or some AWS server somewhere, or having one of the NMC team, or like a salesperson, or even directly giving it to a customer. A lot of time customers may want to have the thing themselves to play with and test out and scroll around. And if that's what you're targeting, then you don't want to have someone go download RobotStudio,
Right.
Do all the install, click all the buttons to get a license. It's not really ideal for a demo. We really want demos to be like very straightforward. Run this installer, done, right? Like let's give as few options as we need to, right? This is really meant to be like a display. And from what I've seen, RobotStudio does have tools like you can do an export that is a view-only export of a station. But the problem is that doesn't include the virtual controller. That's more like you create a simulation, and it's more like a 3D view that has a pre-programmed path. It's more of a recording than really a live demo. So RobotStudio, they take a slightly different approach, just because of the platform, where we're sort of looking for a slightly different thing, which I think is more interactive, and more distributable, because just the target audience that we have.
Yeah, and I don't think they're far off from it, in terms of being able to. It just I wonder if there hasn't been, no one's asked them to do that before, or something like that. I think also, I would be remiss if I didn't mention that RobotStudio is free for 2020. So just to be absolutely clear, because I know there's people yelling at the screen right now that RobotStudio is free to download right now. Please go download it. Please check it out, because it really is an awesome tool. That's not at all what how we're basing this discussion. Just like we want to have this like tiny demo that we can put in anybody's hands, and
I would actually,
having RobotStudio tag along with that is makes it just a bit of a heavier lift.
I would add to that. I'm pretty sure RobotStudio always is free. There's a premium version that has extra things, but I think that the like standard RobotStudio where you do programming is free also.
Well, I think it's the idea is that if you connect it to like an actual controller, like you can use that functionality, but in terms of offline development, that's a separate license.
Cool.
Like using simulation.
Good to know.
Blackburn, do you have any other opinions or thoughts based on what you're hearing, or what do you think? Are we ready to make a decision about that?
Well, sorry, I'd like to jump in a little bit. I mean, we've talked about why. I feel like I've heard a lot of like why we don't want to use RobotStudio and distributability, but like we haven't really talked about what the point of RobotStudio, like why we would consider that versus machine-centric robotics.
That is true, but if the cost is too high, it doesn't matter to me as much, right? If we can't distribute it, then like what we get out of distributing it is less relevant. So if we are saying that we absolutely must not require someone to install RobotStudio, then we need to figure out how to make that happen if we want to use RobotStudio.
I think the upside would, yeah. Sorry, go ahead.
If we can't do it, then I'm less concerned with how great it is.
What the upside is of the impossibility. Yeah, right,
Sure.
right. No, that's yeah. He's optimizing that if conditional out of our thing here. Just for the audience, I think and I guess to give Josh my 1 cent, I think in the real machine we would definitely have an IRC5 robot controller, and a lot of the capability of the machine would be like built into that controller, and kind of having a virtual version of that would make it more like true to the eventual build. But I think with this sprint being focused on like, we want an interactive demo that we can easily distribute, like, and it's, yeah, back to Blackburn. It's just, if it's impossible to do that without RobotStudio, then for now, like, it's a better choice to do the machine-centric approach. And there's cool things we could talk about it being machine-centric. I know we had questions about that last time. What we're leveraging here is the benefit of all, you know, a BNR controller, a BNR virtual controller can run all the kinematics, all the motion control, all the PLC tests, all the HMI tests just in one. That's what we're talking about, being able to package up and send around to people. So I think that might win out here. That'd be kind of my summary. Blackburn, do you agree? Just based on it's impossible
we've
otherwise.
got a relevant question from the YouTube channel from user Bones Jackson. Asked this question last week and kind of missed the window. Says, I know it's not fully released yet, but why not use the BNR machine-centric robotics for this application? Do you really need the power of RobotStudio?
Oh, I love the framing on that question. Certainly coming from a BNR person that wrote that. I would say the power of RobotStudio and the power of machine-centric robotics are both, they're just different. They're honestly just legitimately different things. And the interesting thing, the interesting kind of third option is this EGM, externally guided motion, where you can kind of do both at the same time. And I think that's kind of where we're landing. So yes, it will be running in robots. We will be using RobotStudio for a final build of this machine. I'm pretty certain of that. For the time being, we can just simulate it with a machine-centric approach. So there's no one answer, even in a particular project or development cycle, of like which one needs to be used. They can all kind of be used together, and we see that in real applications in our work all the time. Anybody have anything to add to that?
I mean,
yeah,
I just addressed the fact that, I mean, RobotStudio is and you know, the IRB controllers, like, they are really powerful. And I think that a lot of the users of packaging machines are already familiar with RobotStudio and ABB robots. And you do get a very powerful platform there. When you're going to robot or machine-centric robotics, you know, you're basically taking a lot of the robot and hiding it away in a bit of a black box to a lot of users.
From the operator perspective, yeah.
From the operator perspective, right. And, you know, that's great if you have, you know, a path that's always the same and you want to, you know, it's something that you can just do. But if there's things like you need to do calibration, or you need to do like slight modifications to paths, or there's this obstacle, it is nice to have, you know, for the operator to have the full RobotStudio or some programming platform like that to be able to make those modifications. And, you know, there are cases where, you know, you need tight integration between the machine and the robot, but this doesn't feel like one of those cases. I mean, we're getting a lot of the flexibility from the track system, where, you know, we can do the spacing and adjust the tracks essentially to adjust a lot of the way that we're, you know, picking up the product and adjusting things. So it's sort of a trade-off of, you know, taking the complexity of the robot and putting it into the machine to get that flexibility, or vice versa.
I agree with that, Josh. And I would describe it as fast, but not real time in terms of the motion control and the controllers between the two systems. Like, there are applications that we work on all the time that demand that, but this is more like you could solve it with triggers, right? Like, and that being the case, like, it's nice to bring along all that user friendliness, all those features from RobotStudio that are really awesome and great. So I think, and also because of our skill set as a team, like, it's no big deal for us to run the machine-centric aspects for BNR. We do that so much that it's not, for a lot of companies, that would be a lot more complex, or a much steeper learning curve, just because of how powerful, et cetera, it is. But that's something that we could do, you know, we do all the time. So I don't see a lot of like overhead for us. So yeah, I think for this sprint, for this digital twin, yeah, it makes sense to kind of just do it with the machine-centric or all automation runtime approach, all with BNR components. Then that would save us some of the other questions. But yeah, Blackburn.
Is that the decision?
Feels good to me.
Okay. I will write that down. And we already have that, right? Don't we already have a product that will fill that need?
Yeah.
Josh?
Which need is that? The distribution?
No, running the robot in AR,
Oh, yeah.
running a robot simulation in AR.
Mhm.
Okay, RobotStudio distributability and web to ABB comms is now obsolete, correct? We don't need to talk about that since we're all BNR.
Mhm.
This will get bigger. This is gone. We can talk about later. We are running out of time, so let's hit the highlights before we focus too hard. One thing to remind everyone, part of what we're doing is to have something that is demoable at very short, repeatable intervals. So before getting too in the weeds on one specific task, we want to have enough functionality at all levels. So vertical integration before we finish any piece. Just reminder on that.
Cool.
So coming back to what are the distributables, I think since we are only using AR, we have a pretty good handle on this already, correct? We'll have an installer for the sim and an HMI, and we will wrap that up into one installer as we have done in the past.
Yes.
Yeah. And I mean, this might be a little overkill, but it does, I mean, I do just want to make sure we are talking about running, you know, for the HMI Electron and just AR sim. We're not talking about anything on the web. We're not running this on some server somewhere. Okay.
Not yet.
Save it for season 3. or yeah.
I think this is a more detailed question that we could maybe tackle later. Are we talking about doing any DevOps integration at this point? Wait and see.
Well, I mean, can we talk about what we hope to get? I mean, are you talking about like just for like auto releasing demos, or are you talking about more than that?
Everything's on the table. What could we add in this 6 weeks, and is it interesting enough to do?
Well, I mean, I certainly think that it would be hugely beneficial to at least have some auto build, auto generate the executables. And I don't think there's not a whole lot. We already have a lot of infrastructure in place for that in other places. So I think porting it over to this would be, you know, especially early on, so that we can really get releases out quickly. I think it could be very beneficial to do that. Definitely worth it.
I would
if
add,
it's later on.
Yeah.
So good.
Yeah, I agree with you. I would agree with you, and I would add, for anybody hearing buzzwords, which we love, like DevOps is something we're really excited about. What we're talking about is when we are working on the software in Automation Studio, when the devs are making commits, and you know there's a big team of people, or at least more than one person working on the software. When we make commits into our source control system, which we use GitHub, it will GitHub and some of our cloud systems will check out that code, build it, create all the installers for the demo, and then make that available to people that have access. So what that means is that not all of that packaging activity to, again, put it in the hands of a salesperson is happening in the background instantaneously. Any check-ins you make, or again, there might be tweaks to that, but like the check-ins, you can instantly make those in an automated fashion instead of having to package that up, or instead of even having to have, bring along your developer so that they can run a demo for a customer. Those are things that we can basically instantaneously generate on the backend systems, which has been a really powerful tool for us and something we're really excited about talking about more of. So anyway, that's background on what we're talking about here. And yeah, I think to have that especially early would be great. That way, any commits or any changes that people make, any tweaks or people making hour by hour can be seen by anybody who can get to the releases.
Okay, all in agreement there?
Yep.
Yeah.
Okay, both of these I think are, you know, this is part of this. We talked about product modeling, how much we're going to model the product infeed and outfeed. We talked about the stages: coming in, going to the track, moving around to the robot picks it up and drops it off, and then it leaves. Not sure how much of this we need to decide early on, or just say that, yes, we'll make appropriate level of detail as time allows. Is that good enough for now?
Yes, more than one product and less than infinite product, less than infinite variability is our bracket so far. But
Well,
I
so
guess you're not even
like
talking about product. You're talking about how much fidelity to put into the
demo.
input and output,
Yeah.
the demo.
Like,
Yeah.
are we dropping them at the end and they just like shatter on the ground, or do they disappear? Are you talking about like,
Yeah.
Do we
it's
animate a
sliding
conveyor
down?
belt?
Yeah.
I think to your point about let's get it all running, a stream. I like the idea of the lateral move because I feel like that's a critical thing, and I'm talking about the infeed mechanism. And it wouldn't have to be like tipping over, but like the idea of it's, you know, a constant stream coming in at an angle, it slides on to the carriage because they're synchronized. That to me would be my like first starting point. Or like I would love to show that in the demo. And on the outfeed, what we did in the previous animations that we just did in RobotStudio was I think the product just disappeared when the robot let go of it, because you're just like, we just placed it in a box, right? And it fell down and faded out, I think, was, if I recall correctly. That's acceptable to me because you can see the product, you can see the case configurations. I mean, if you set the case down and then it shifts on the conveyor, like that's fine too. But I think like when the robot lets go of it and you can see, okay, that's where it goes into the case. Like that to me would be my like my minimum boundary.
So I guess, you know, one thing I think about is, you know, we've got, if you imagine you've got like an STL of a bottle, you know, there are ways that you can move that around. One would be just, you know, essentially like we have some model of where it is, where it's moving along. We know it goes down, we know it goes around. You could do something like that. Or, I mean, if you want a slightly higher fidelity, it's like, okay, well, there's this thing that brings it over here and it comes down, and then you say like, okay, attach to this. And if you say attach to this, then it will sort of like physically be on the thing, right? And then it comes around and, you know, the robot picks it up and it's like attached to robot, right? Where it's sort of being passed around on these things instead of just like calculated position of where it is, right? I think those are like, even that I think is a question of like fidelity. Like that would be higher fidelity than just a path of calculating where you think it should be.
I think that's a degree of that we would want to leave to the developer, you know. And if we're interested in talking about the possibilities, because they're the one who's going to have their head in it close enough to say like, here's what's harder, or here's what's more or less difficult. On the one hand, if you just say tag it to something that's already moving in the correct position, starting from it being aligned, like that sounds easier. But then you can't just smash it over here. You know, you have to deal with all those transition points in it, and that could end up being more complicated. So I don't know if you're making a suggestion or you have a preference. Should we leave it to the dev on like that implementation detail? What do you think?
I mean, I think it'd be a lot cooler if it like switched to things. I think it would. I don't think it would necessarily be that much more complicated. Although you would get some weird bugs possibly where like the thing actually just like is off in space. That could happen. But that's
Right.
good information to know, right? I mean, that's part of it.
I like the idea of attaching it, and you said STLs too, and I think one thing that one simplification, or like one boundary that we could make, is we're going to deal with round things, and in that case it's a cylinder. 3JS cylinder has attributes that are easy to manage, and at least I think it does.
Yeah.
And if that was the case, then we could deal with colors and materials diameters, heights, just within that primitive, just within the 3JS primitive of a cylinder. So that's a suggestion. It wouldn't have to be that way, but I feel like that could be a cool way to do it.
Yeah, I agree. That's an implementation detail, and I agree that it makes sense to me to attach it to things. The track API has outputs already for like global XY.
Yeah,
so I feel
and
like that
rotation.
could be
Yeah,
pretty. Oh yes, yeah. So that could be pretty easily brought
Sure,
in.
but that's the track, right? That's not necessarily a
for the
bottle,
carts,
right?
that would be for the shuttle.
That's the cart,
but then,
right?
But then when the thing laterally moves down, it's like, okay, your parent is now the shuttle, and then the shuttle position is getting fed from automation runtime. That would, at that point, the cylinder would be tied to it. So that could be a good place to make the arrangement. Or likewise with the end effector. Once it's pinned on the end effector, and I guess to that end, we might not even need to put the fingers on the end effector. If you just see like pin it on the end effector from where the pickup point is, then you'd see the 6-packs or 4-packs moving the way that they're supposed to. So that could be another nice shortcut. But again, development detail. I like the pinning idea too.
Yeah, I think whatever makes the math easier on the HMI implementation.
Yeah, right.
Yeah,
right. Agreed.
Need to show sync between infeed position and the track position, and then the product can disappear after the robot drops it. That's what we're going to go with first.
That's a good start.
Okay. Then this is next. We kind of got where we want to go. I haven't looked at this in a while, so I don't know what's left. But I think that's probably more implementation details than we need to get into right now.
Cool. Yeah. Let's bring them in the infeed and get them in boxes, and then we can talk about how to divert and add on to things later on.
All right.
Good. Cool. I see demo 1 May 19. That seems intentional?
Yes. So as far as I know, this week and the past week, we're going to do scoping, and then development starts in earnest on May 5. That works out, right? Tuesday. We do 6 weeks to June 16th, and I put in nominally 3 demos once every 2 weeks to be scoped once we figure out how much we can do in 2 weeks.
Cool.
Any objections to 3 demos? Want to do 2 demos? I want to do more than 1 demo. That's for sure.
Just show up at the last day. I'm sure it'll be fine.
Yeah, let's not do that.
Yeah, okay. Cool.
Any opinions on 2-week demo versus 3-week demo versus 1-week demo? Okay, 2 weeks it is.
2. Well, we might have more opinion after the second week. We'll see.
Yeah.
Yeah.
They might want to be more frequent or daily or weekly.
Could be as frequent as is interesting,
Right.
Right. Yep.
Okay, cool. Well, that all makes sense. It's 10:33. We're almost on time. Anybody, David, you can unshare for a second, and I'll just go back to this. Does anybody want to? Any other comments? And I'm excited to get started and start seeing this happen. Anybody else got anything else before we bounce? Allison, Jeff, you're quiet, so we'll catch you next time. Thanks everybody for joining us. See you on Tuesday, 10 a.m. Bye.
Everybody, bye.
Thanks,
Stay
everyone.
well.